Hello, my name is Julian Castillo and my friend Jose Rolon. We are gonna talk about the ideal gas. So the introduction, we are gonna ask those questions. So what is an ideal gas? What is the ideal gas law? And we are gonna exploring behavior of the gases through science and experiments. So what's an ideal gas? An ideal gas is a theoretical model of a gas with particles that have no volume and no intermolecular forces, and all collisions between particles are perfectly elastic. While no real gas is truly ideal, the concept allows for simplification and approximation that accurately describe the behavior of real gases, especially at high temperatures and low pressures. What is the ideal gas law? The ideal gas law is a fundamental equation of state that describes the relationship between the pressure, volume, number of moles, and absolute temperature of an ideal gas, represented by the equation PV equals N times R times T. So we can see depends the variable that we're looking for, we just got four new equations. So the experiment that we're gonna show you is called the zombie gloves. With the experiment, we're gonna demonstrate the basics physical principle related to fluids. We're gonna need a glove, half a bottle, and a container with water. So what we're gonna do is attach one of the gloves to the half of the bottle like that. We're gonna use a rubber band to just keep it on straight. And we're gonna put the bottle in the container with water. And we can see the gloves inflates. That's the air pressure and the compression. That the air inside the glove is trapped and less dense than the water. And the external water pressure compresses air inside, but since the air is compressible, it's pushed back against the water. So we're gonna solve a physics problem involving a steel tank containing oxygen gas, given the amount of oxygen, tank volume, and the temperature. So we will calculate the initial pressure inside the tank using the ideal gas law, and then we want to explore what happened to the pressure when the temperature increased significantly. So the statement problem is a steel tank of 10 liters contains 0.8 moles of oxygen and a temperature of 27 degrees. So calculate the pressure inside the tank in atmospheres and what happened if the temperature increased to 127 degrees. So for the initial pressure, we just got the number of moles, that's 0.8, multiplied by the number of. So for the initial pressure, we just take the 0.8 multiplied by the 0.0821 times the 300 divided by 10. And we got the pressure, the initial pressure is 1.97 atmosphere. And for the final pressure, we just take the 0.8 multiplied by the 0.0821, then multiplied by the new temperature, that is 400, and we got divided by 10. And we got the result, it's 2.63 atmospheres for the final pressure.